Recording is started. Yeah, so welcome to Monday, August 15th. Before I get going on the main subject day, I want to take a look at what's on AP Classroom. All right, so I need to get a few days to go over some basics with you guys, some math basics. So I'm going to take today to do some algebra stuff, tomorrow to do some trigonometry. Wednesday, I want to do some basic science stuff with you guys, SI system, measuring tools, dimensional analysis, that sort of thing. Couple ideas for what we might do Thursday, Friday, but when we get closer there, I'll figure that out. And the first main topic that we're actually starting probably by next week is going to be kinematic motion. So I did go ahead and put unit 1 up on AP Classroom, and then, you guys see unit 2 also. So that's like after that. So when we get to actually like forces and what causes accelerations, that sort of thing. So those are up there. Those due dates are probably going to change as we get closer. But if you wanted to have a sneak preview, look ahead a bit, those are up there. Okay. Something else that's here. Let's see, is this going to, okay. All right. Okay. Yeah, let me switch this window back and forth. Whenever I put in this, the second screen looks like it's chopping off some stuff I can't quite get to. But if you go to course resources, I think some of you guys have already checked this out. There are some daily videos. So yeah, again, if you want to look ahead a bit or see a different perspective on some of the things that I talked about in class, those are here. Again, I'm not going to start talking about kinematic motion. So we're talking about displacement, velocity, acceleration type stuff until probably about next week. Possibly get a lab going for you guys by the end of this week, but so there. All right, so all the stuff is there. Those resources are there. There are 34 students in the class. I checked last night and 25 of you have signed up for this. You guys remember on the syllabus, there was a Google Classroom code and also an AP Classroom code. Okay, so you should be signed up for both of those by now. I think I need 9 of you still to sign up for AP Classroom. So if you haven't done that yet, then that is there for you guys. Okay. And yeah. All right, that whole recording that did not capture on. Okay, so there we go. If you're watching this recording, well, there you go. This is what that looks like. All right, so let's switch back over to we're doing today. Right, now you guys have a page on your desk. It says algebra homework on it. It says half page. I'm not actually going to assign this for homework, but I do want to do some of these problems with you guys. So we're going to take a few days to make sure that everybody's caught up to speed with a lot of the math that you need for this class. So let's look at a bunch of algebra concepts today. Okay. Starting with solving for x, and then we'll get more complicated as we go along. All right, so let's pick, say, how about number 7 off this page, off this half page. Okay, here's the front and the back. I'm just looking at the front right now. So number 7. So this says, you know what I'm going to do too? I'm going to change, see where it says P. I'm going to change that to, never mind. Scratch this. Let's start with number 1. Number 1. Okay. So number 1 says -20 equals -4x minus 6x. Okay, here's it. Okay. Now, usually in algebra, if you're solving for some unknown quantity, it's x. Little bit of history behind that. Do you guys know where algebra comes from? What region of the world?
Middle East.
Middle East. Yeah. In fact, anything that starts with AL, that's from what language? Arabic. Yeah. Yeah. And so if you go back hundreds of years ago, when algebra comes from the Arabic world, they were solving for how many guys in here speak Arabic? Speak Arabic? Okay. What they would be solving for was called al-shayan, which was the unknown quantity, like the unknown thing. Now, Arabic influence came into Europe and therefore the Western world through one way was through Greece, because that was the geographically the southeast part of Europe. And so in the Greek language, they used the character chi. Chi looks like this to represent, in Arabic, what they were calling al-shayan, the unknown quantity. And then the other place that Arabic influence came into the Western world was through Spain. How many guys speak Spanish? Yeah, just Spanish out the sound sh. Is that part of that language? It is not. So they were running into the dilemma of what do they call Al-Shayon, right? Has the same. So they borrowed from Greek. Got this Greek letter chi that turned into the Latin X, and ever since then, X has been like the unknown quantity to solve for. So here we go. Here it is. So see, we're trying to figure out what is X. Now, when you see an equation like this, just algebra review, you're trying to figure out what could X be so that it would satisfy that equation. Now, you could sit here and guess and check, say, I'm going to plug in 1, I'm going to plug in 2, I'm going to plug in 3 until you find something that works. Okay. Or there's a process, right? And the process is that you undo everything that's there, combine like terms until at the end of this process, you'll get finally X equals something. Okay, that's what we're going to do. Now, I see 2 things that have the X in them. I got 4 of them here and 6 of them here. Well, they're negative, but okay. So we're going to tag these together and make it like 10 of that thing, but negative. So leave this guy alone. Right. These guys together give you negative 10x. Right. Solve for x. Right. Okay. All right. Now, what I'm trying to solve for, if I were to multiply it by negative 10, then it would be negative 20. So I have to undo the negative 10. Right. And that's going to, you get there by dividing both sides, right? So divide by this coefficient. As long as you do it to both sides, it's balanced. Okay. See where that gives you a positive 2 is equal to x. Right. So there it is. Okay, so x would have to be equal to 2. Now, sometimes, especially after a long algebra problem, it's a good idea to check your answer, like going back and plugging it into the original statement. Okay, so let's just see if that works. So if I plug in 2, right? So negative 4 times 2, that's negative 8. Negative 6 times 2 is negative 12. Negative 8 and negative 12 makes negative 20. So we're good. Okay, guess that? Okay. All right. Now let's go do number 7, which looks like p minus 1 is equal to 5p plus 3p minus 8. Okay. So the variable here is now called p, which is good practice because in physics, you could be solving for all different kinds of variables. It's not necessarily just x, right? X is a pretty generic thing to solve for, but now switch over p.
I think that's question 6.
Is that number? Oh, you're right. I did new. Okay. Oops. Yeah, good call. Well, I guess we're doing number 6. Yeah. Yeah. Okay. Yeah, that's a typo. I guess that's the answer. Yeah. All right. Yeah. So yeah. So number 10 only has one choice, and yeah, that's how it works out. All right. Yeah, it just says 0, and the answer is 0 for number 10. Okay. All right. So here, I'm gonna combine my p terms. Treat p kind of like x. So I got p minus 1 still. It's equal to, it's going to be 5p and 3p makes 8p. Right? And minus 8.
Good morning, Hawks. Happy Monday. Hope you all had a great weekend. Teachers, at this time, let me ask you to look over your classes and conduct your 6-day count. Please remember to cross out any students that you have not seen at all this year. If you've seen them even one day, please leave them on your roster. If there's anyone in front of you with a schedule showing they're in your class and is not on your roster, please add their name to your roster. After you've completed it, please tape it to your door. All buses are currently in, so there shouldn't be additional students returning to class. At this time, all your students should be in class. Also, teachers, this morning, the Squire sent an email starting today. Eastern Florida classes will begin. And so at 10:15, students will need to be released to ride the bus to Eastern Florida. Ms. Squire sent the email of who those students are, so please allow them to be dismissed at 10:15 and to go to the front of the school to catch their bus to Eastern Florida. Thank you. Have a great day, Hawk.
Yeah, so I've got 4 terms, right? Point. Okay, I'm going to get the p's together, and I'm going to get the constants together. So let me subtract p from both sides. Minus p minus p. Right. Okay, so that's going to look like negative 1 is equal to 7p minus 8. Then I'll take this 8 and I'll add it over. So plus 8 plus 8. Remember, as long as you do each operation to both sides, you're still balancing the equation. So that looks like 7 is equal to 7p. Divide both sides by this coefficient 7, kind of like we did up here with the negative 10. Okay. Divide both sides by 7. and that's 1 is equal to p. So p must be equal to 1. Check your answer. So if you take this plug back to the original statement, 1 minus 1 is 0. And over here, 5 times 1 is 5, 3 times 1 is 3, 5 plus 3 is 8, minus 8 is also 0. So 0 is equal to 0, so it checks out. Okay, that's good. All right, let's look at a different interpretation of this, which is the good thing about this is graphing. Okay? You guys know like y equals mx plus b. Okay, let's see what this would look like as graphs. Because you could treat p kind of like x, like an x variable. And what if this was like y equals x minus 1, like as an equation? Okay, so y is equal to yeah, let's stick with this notation, p minus 1. Okay. It may be a different y equals, and then I'll have this equation. I'll just call this 8p minus 8. Is that okay? So y is equal to 8p minus 8. Okay. Could this be like a system of equations? System of equations. Okay. And you already know what the answer is. Right? In fact, let me just write that here. Answer equals p is going to be equal to 1 because we found that already. Okay. And if you plug that back into the original equation, remember this was equal to 0, 1 minus 1 is 0, and also all this comes out to 0. Okay. So this is like a coordinate, right? And I'm going to show you guys the graphical interpretation of this. Okay. So get a set of axes going. Instead of xy, I'm going to do py. Okay. Get you guys used to like swapping out different characters, different letters for these variables. Okay. Hey, y equals mx plus b. Does this have a slope? What's the slope for the stock equation? 1, because there's an applied 1 right here, right? 1 over 1. And what's the y-intercept? -1. So go down here, -1. There's definitely a point here. Then up 1 over 1. So all of these points would lie on the line, right? For example, 1, 0. You plug in 1, 1 minus 1 is 0. Right? If you plug in 2, 2 minus 1 is 1. So here's the point 2, 1. Okay. You have like all these points that are going to lie on this line. Okay, and satisfy the top equation. How about the bottom equation? 8p minus 8. So, -8. That's a huge negative y-intercept. 2, 3, 4, 5, 6, 7, 8. This fits on my paper. Down here at the bottom. Okay, here's your y-intercept. It has a really steep slope. Look, rise over run at 8. Right? So, for example, if you plug in 1 for p, yeah, 8 minus 8 is 0. That's also this point. Right? That's going to be a really steep slope. You guys see that? So this line right here. Right? So whereas this has a rise over run 1 to 1, this is like an 8 to 1 slope. Right? And look where those two lines cross. You guys see this point right here? It's the coordinate 1, 0. You guys see that? Oh, that was also the answer, right? P is equal to 1 and y is equal to 0. That's good. Okay. Let's look at number 5, because this one's a little weird. Yeah, those were done. Says 4m minus 4 is equal to 4m. Okay, so I subtract 4m from both sides. It gives me -4 is equal to 0. All right, well, a couple problems. One is that when I'm solving for that m, it's gone. So how can I solve for it? But also I'm left with a statement that's not even true, right? -4 equals 0. What? We've been following this process, and now we use that process and we're getting something that looks like it's blowing up. So what is the answer to this? No solution. Good call. No solution. Okay. And what does this look like graphically for it to be no solution? Well, let me start with this guy right here. Let's call it y equals 4m. Right? I'll treat this as an equation. Y equals 4m. Okay. So here's m. Here's y. Well, that would just go through the origin as a rise over run of 4 over 1. Right? 4 over 1. That would be that equation, right? Y equals 4m. Okay. And then this could be y equals 4m minus 4, which is the same thing as shifted down 4 units. It is. Yeah. So if you have parallel lines, the fact that those lines never cross also means that there's no solution, right? There's no place, no point to cross. You guys get that? Okay. All right, let's do a distribution. How about number 17? Looks pretty fun. Number 17. Right, so got negative 1 plus 7x minus 6, negative 7 minus x is equal to 36. All right. So do you guys remember distribution? Okay. Now really sort of have three terms here, right? This term, and then 36 by itself, right? Point. Okay. I have a negative sign that really applies to everything on the inside here. So I can distribute that negative sign. Okay. And it's negative 1 minus 7x. Okay. Then that negative 6 distributes. Right? Now, negative 6 times negative 7 is positive 42, and negative 6 times negative x is positive 6x. Is that okay? Right, basically. All right, then I've got 5 terms at this point. 2 of them have the x, and 3 of them are just constants. All right, so let me get all the x stuff together and all the constant stuff together. So if I combine the x's, well, let's see, combine everything on the left side. So negative 7x and 6x is negative x. This stuff put together is positive 41. That's equal to positive 36. Okay. Subtract 41 over. And negative x is equal to negative 5. Therefore, x must be equal to 5. When we divide both sides by negative 1, right? Right, is that okay? If you plug 5 after the original statement, should be left side is 36 and the right side is 36, and everything should check out. Okay. Guess that. Okay. If you flip the page over, see a bunch of square root looking stuff. So let's pick one of these. How about number 32? 32. Right, so negative 10 times the square root of v minus 10 is equal to negative 60. Okay. Okay, well, it looks like you're solving for v, right? I wonder what v is. Okay, so v is, let's see, it's buried underneath the square root. That's also multiplied by some multiple, right? So we have to unbury it a few times to get to finally v is equal to something. Okay? What's the very first thing we're going to do both sides?
Divide by negative 10.
Yeah, divide by negative 10. Divide both sides by negative 10. Good call. Okay, so now I'm just the square root is equal to positive 6. Okay. Next step. Square both sides. Right? Okay. You know what I should really do? Switch heat color here. This one. Square both sides. Okay. All right, so that will undo the square root on the left side, leave me with just plain v minus 10. And on the right side, I'm getting 36. Okay. And what's the last step? Yeah, add 10 to both sides. These colors are too close together. Better than nothing. So it's going to leave with just plain v, which is, that was the whole goal, right? To isolate v. Okay, I'm getting 46. We show it's a choice. That's an answer for us. I think that looks good, right? V must be 46. Okay, guess that. Okay, questions so far? Okay, I want to throw a little challenge for you guys. We're going on one step harder here. Okay. Number 17. Oh, we did that one. Here we go. Right. Okay. You guys all okay so far? All right. So I'm gonna. Okay. So this page is really just extra practice for you guys. So if you feel like super comfortable with everything so far and some of these other ones, then you're probably all right. If you feel really rusty on this, that is a sign you should definitely take this home and do extra practice for yourself. But it's gonna be a song. Okay. So, all right. Let's do this. Suppose we got t squared plus 4t is equal to 21. Okay. Solve for t. All right, he's got to figure it out. But Matthew, what you got?
I got E equals -7 equals 3.
Ah, two answers, right? -7 and 3. All right, how many guys got that? Who guys got that? Oh, okay, you guys are on. All right, so in case you need to see how to do this, let's do this real fast. So I can think of a couple ways to do this. You made it factored. Or how about this? And we got to get this 21 over to the left side, right? Because what form is this going to take? Starts with a cube, quadratic, right? So I can get this like ax squared plus bx plus c is equal to 0, right? Whenever see like math form, right? What you're solving for is squared and then not squared, and then there's a constant. If you get all set equal to 0, now it's in that form. And now you might have done this factoring method, like this. Okay, it's two things that add to 4 but multiply to -21. Well, that's going to be your it have to look like this, right? T plus 7 and t minus 3, right? Wouldn't that be true? Okay. Right, and then okay, so you guys remember FOIL, right? FOIL. Maybe jot that down. So I sort of did like the reverse of that. So to go from here back to the previous step would be FOIL. So first outside, inside, last. So t times t is t squared. We got -3t plus 7t brings you up to 4t, and then 7 times 3 is -21. Okay, guys know that? Okay, so reverse process. All right, now if we have two things multiplied together that equals 0, which wasn't true in this line, but it's now it's true in this line. Okay, that means if either one is 0, the whole thing is 0. So if this is 0, well, t must be equal to -7. And if this is 0, then t must equal to +3. Okay. And there could be a physical interpretation of this too, because all these equations are going to tie to physics. So I'll give you guys an example. Okay. Suppose that you were like up in a tree house and you were throwing a ball straight down to the ground, and you want to know how much time would it take for that ball to reach the ground. You could set up an equation that would eventually look something kind of like this. Okay. And it might take like +3 seconds. Right? If it's a super tall tree house, you like chuck it straight down. I'm not dropping it, I'm throwing it. That's what make it look kind of like this. You'll see this a few weeks. Okay. So it might take 3 seconds to reach the ground. But then what you could say is, well, what if you to reverse the footage, but instead of catching it, you just let it go ahead. It might go into like some parabola type shape, and then also hit the ground like 7 seconds before. So that's what the -7 is. That might be that interpretation. Right. So you guys can do quadratic. Oh, sorry. The other way to solve this is to use quadratic formula. So I got t equals, right? Remember now this would be play off this form right here. Remember. Okay. Yeah. So you check the ball straight down. It takes 3 seconds to reach the ground, right? It takes 3 seconds. That's it. Whenever you're dealing with time, sometimes people even say you only take the positive answer, but there actually is an interpretation for the negative answer. And the negative answer is, suppose you put the film in reverse, starting from the ground. You guys think it would take 3 seconds to go back to the starting point where the first about to shut it down? But then what if you said, well, what if there was like an identical ball that wasn't thrown, but maybe it was falling like side by side that also came from ground level, just came from the ground level, like over here. Just something kind of like this, like pretty much straight up, straight down, right? Okay. Well, it would take some amount of time also to reach the ground from this point. Okay. So if I'm saying like how long does it take the ball go from the treehouse to the ground? Well, you could throw it forward in time, or you could say, well, it could have come from backward in time, like from the ground to the treehouse, right? And that would be a 7-second gap, but it'd be 7 seconds reverse in time, right? Okay, that's it. Okay. Yeah, so the other way you can do this is t equals -b plus or minus square root of b squared minus 4ac all over 2a, where a is equal to 1, b is equal to 4, and c is equal to -21. You guys remember that quadratic formula? Okay. So this is like a general solution to anything that looks like this. A t squared plus bt plus c is equal to 0, but you have to have it in the form, right? Equal to 0. You guys remember that? Any questions so far? Okay. You guys had some good questions so far. So, all right, let's go a step more challenging. Okay. There's many times throughout the year you're going to see some version of this. Okay. Ooh, where'd all the numbers go? Can you solve for v in terms of the other variables on the board? Give you guys a little time to do that. Solve for v in terms of everything else. And the answer isn't just going to be a number. It's going to be bunch of variables, right? So solve in terms of variables. All right, who's got the answer? Who's got it? Right, what you guys do?
Square root of 2gh.
Square root G. How many guys got square root 2gh? Square root 2gh. All right, you guys got it. You guys got it. All right, so let's go through this. So I'm trying to say ultimately b equals something. I'm going to use that algebra process. Okay. Hey, could I divide both sides by m? Right. Or if you like, you could just say m cancels out. Right. Okay. So the in physics, that's going to stand for the mass of an object. Right. So it's like whatever the mass is just ends up not mattering. Right. So gives me 1/2 b squared is equal to gh. Right. Then cross multiply this 2. Right. So multiply both sides by 2. So times 2 times 2. Okay. That'll give you just plain v squared is equal to 2gh. Okay. And then the last step is to square root both sides. Square root, square root. So v equals square root 2gh.
Wait, would it be plus or minus square root of 2gh?
Ah. Okay.
Because
Mm,
square can have like 2 values.
That's a good point too. Yeah, plus or minus. Yeah, maybe this looks like a plus or minus. And then how would you interpret that? So yeah, that's a good thing to think about too. Like math and physics a lot of times will play off each other. So you can do like some theoretical math work. It's like, hey, what's this negative sign mean? And then it actually opens up like a good interpretation too. Yeah, I'll show you in a minute too. Because there's a 1/2 here. So like, how do you undo the 1/2 coefficient? Okay, you can either divide both sides by 1/2, but that's also the same thing as multiplying by 2. Okay, because my end goal is to get like v equals something. Okay, so let me show you guys the physics interpretation of pretty much this equation. Okay, suppose you go back to that tree house, and but this time you're just going to drop the ball from the tree house. You're not actually going to throw it. You're just going to go ahead and drop it. Right? Or a lot of times I'll use the example of if you go to the edge of a cliff. Okay, suppose that this height change was just h. You're in a gravity. Hey, do you think if you drop something on Earth, it's going to fall faster, faster, faster as it gets towards the ground? Right? Yeah, it will. It'll pick up speed faster. Like, you know, here, if I drop something from like 3 feet above you, would you want to catch it? That'd be okay, right? What if I drop something out of an airplane? You still want to catch it? Probably because it's picking up so much speed. Like, get out of the way, right? Okay, so the amount of time it's falling for that probably has something to do with how fast it's picked up to, right? It's in a gravity field. Do you think the gravity field is different on different planets? Like on the moon, it's really weak. Okay. And so we have some gravity field. That's at G. There's some height that's going to fall H. Maybe the ball that you're dropping has some mass M, which ended up canceling out. So maybe that actually ends up not mattering. That's interesting. And it's going to pick up to some. What do you think V stands for? Velocity. So that by the time it's hitting the ground, it's going down at some V velocity. Some speed. Okay. Now, Stu, you brought up a good point. What's up with this plus or minus? Okay. Well, you might say if you drop it from rest, it'll pick up some velocity. Now you have to define some direction, like which direction is positive and which is negative. And it's arbitrary. So let's suppose you define down as positive. Okay? You could do that. Okay? But what if you had thrown a ball upward from ground level? Right? Wouldn't that be traveling in the opposite direction? It would have the opposite sign. And then to get to the top, it would also have to go. It would be this height and this gravity field that was going against it. Right. So to go from this point at rest to the ground, well, it could go upwards to get to that point, or it could be going downwards coming from that point. Right. And that's a plus or minus. Right. You could throw it that fast to get it up there, or if you dropped it, it would go that fast, opposite direction by the time it got to the ground. All right, how about here's another one you guys are gonna see at some point. Solve for this v. What do you get? Is the math going to cancel out just like before? Yeah. Divide both sides by n. Now what should I do?
Multiply both sides by r.
Exactly. Yeah, multiply both sides by r. Right. So at the same time, I'm going to swap both sides. So that gives me v squared is equal to g times r. Okay. Then what? Square root. Did you guys get the square root of gr? Boom. All right. Yeah, you guys are solving physics equations. Let's do another one of these. Let's do another. Yeah. But this. Can you solve for a? Actually, before you guys, okay, go ahead, solve for a. I guess got the answer. What do you get, Jack?
2x over t squared.
2x over t squared. Is that what everybody got? 2x over t squared. All right, looks good. Okay. Before I take you guys through that, what do you guys think the t stand for? Time. So okay, so we've got some time ticking by, tick tick tick. What do you guys think the x stands for? Okay, could be position. Could be displacement. If you start from position 0, it's going to be displacement. There's actually different interpretations of this. Could be like location, position. Could be displacement from the point that you start with. I'm usually going to write the notes in terms of displacement, but either way, guys. And what do you guys think the A stands for? It is acceleration. Right now, this is kind of next week stuff, but just a little preview. It has to do with the rate that you're speeding up or slowing down. See, if you drop something on the moon, it'll speed up towards the ground, but just at a slow rate. Versus if you drop something on Earth, it'll also speed up towards the Earth, but just at a faster rate. Right? That's kind of what that. Right? Okay, so okay. So if you like drop that ball from the tree house, and you had these different variables going around, and you wanted to solve for, hey, what is that acceleration in terms of how long did it take to get to the ground based on some drop height, right? You guys kind of see how this is fit together. Okay. You can just do some algebra and figure that out, right? So multiply both sides by 2. Divide both sides by t squared. Boom. Okay. Good. Yeah. Go ahead.
What's the difference between like acceleration and velocity?
Acceleration of velocity. How about this? Yeah, a little next week's type stuff, but I guess you guys get to see this a couple of times. Suppose you're looking at your speedometer, right? You guys ever see like the needle on a speedometer? Right? Suppose it's pointing to okay, I kind of hate to do this. I might never do this, but I'm going to use miles and hours, like miles per hour. Okay. Suppose you're going 30 miles per hour, right? Is that okay? In this class, I'll almost never use those units. I'll always use like meters and seconds and like metric system, but just for today, right? Okay. If that needle is just constant 30 miles an hour, so we got 0, 10, 20, 30, okay? That could be like your speed, like your velocity, right? It's just like that. Okay. But what if you step on the gas pedal and that needle starts to move? Okay. Now, if you step on it a little bit and it starts to move pretty slowly, I think that's pretty small acceleration. Versus if you slam on it, it goes zoom, just starts zoom. Okay. Do you think it's a greater acceleration? Can you really feel that in the car? Like, oh man, I just pounded that gas pedal. It's the rate that the velocity is changing. Yeah, that's what acceleration is. Okay. So 40, 50, 60, let's go 60 miles. Let's go up to 70 miles an hour. 70 miles an hour. Okay. Yeah. So here's the definition of acceleration. Acceleration is the rate change of velocity. So I'll go final velocity minus initial velocity, all in the time period that it takes. Okay. So suppose the needle moved from 30 to 70, and it did that all in a period of 2 seconds. Let's say it takes 2 seconds to go from there to there. What would like the acceleration be? Okay. So that's going to be, well, the final velocity was 70 miles per hour. The original velocity was 30 miles an hour. And you made that change all in 2 seconds. So you changed 40 miles an hour, and you did that in 2 seconds. So 40 divided by 2 is what? Right? Okay, so 20 miles per hour per passing second. Can you guys see every passing second that needle picking up another 20 miles an hour, which is a pretty bonkers acceleration, right? It's actually twice the free fall rate, but to do that, super powerful car, right? I guess that. So it's like the rate that that needle is moving. Okay. Let's do this. This will be a either December or January, depending on how this works out. You guys can see an equation that looks like this. Has to do with the time period of a pendulum, like a pendulum swinging back and forth. Pendulum clock. Okay. Suppose you're solving for that. Okay. Can you guys solve for that? Stay a step ahead of me. Get me to the answer. You guys remember cross multiplication? Cross multiply? You guys got the answer before I did? You guys beat me to it? You guys get something like that? Is that what you guys got? All right. All right. Okay, so yeah, see now you have ways to solve just solve in terms of variables, right? So like if you knew this equation, actually you guys are going to experimentally get well, figure this out proportionally. Have a lab line for you guys many months from now. Okay. So let's see if you know what do you guys think that L stands for a pendulum? Like the length, right? Length of a pendulum, right? Now this is assuming you put all the mass in the bob, so you have like a massless string. Okay? What do you guys think capital T stands for? Yeah, time period. Maybe the time to swing back and forth once. What do you guys think G stands for? The gravity field you're in, which is an acceleration, but what type of acceleration? Yeah, like the gravity pull of a planet, right? Like, so you drop something, the rate that it's picking up speed as it's falling towards the earth. Okay. Now, of course, this case it's the pendulum, but hey, you could maybe like bounce around different planets, like you're right. And it's like, okay, if I pull up my pendulum some length, you know how much time it's swinging back and forth. I know what the gravity field is. Okay.
Wouldn't acceleration actually be the rate of change of speed in displacement equal the rate of change of velocity? Because wouldn't the displacement be like plus or minus acceleration?
Okay, so yeah, we're looking at here is okay, go ahead and give guys a little bit later notes then. Okay. So displacement is measured in displacement. We're going to measure in meters. Instead of feet or miles, we're going to just be using meters. Okay. If you want a velocity, that's going to be in meters per second, right? Instead of miles per hour, we're going to be doing meters per second. Right? And that is the rate change of displacement. So it's like change in location per change in time. Delta T, sometimes used for like time interval, right? Now, if you have an acceleration, well, the example I was sort of using before was I was saying like a rate change velocity, like miles per hour per passing second, like the rate that needle is moving. Now, we're never going to use miles in this class. We will use meters and seconds. hey, that'd be like distance per time, right? Instead of miles per hour, it's gonna be meters per second, okay? If I had meters per second per passing second, meters per second, could I combine the 2 seconds together? Meters per second, that would give me what? Meters per second squared. Meters per second squared, okay? Okay, so that's what we did, and that is the rate of change of velocity, change in velocity per change in time. Okay, all right. Okay, let's look at some basic graph shapes. Okay, now if you guys looked at that big old review page that I gave you, you guys remember the very first the school. Here it is. Give you guys a packet that looks like this. Isn't that? Okay. Well, I just want to point out that this is here. On the back side of the front page, see where there's these basic graph shapes right here? Okay. These are almost all the graph shapes that you guys are going to see throughout this class. Yeah, I'm just pulling out this packet just to point out that those are there. The only other one that's on the front page, it's the sinusoidal, like the sine looking curve. Okay. So let's go over all those. Of course, these aren't all the graphical relationships that ever exist, but these are pretty much the only ones that you care about for this class. Okay. Okay. And I want to walk through like why each one would be what it is. It's a place for you to see it. Okay. So let's put X on this horizontal axis and Y for this vertical axis. So X and Y. But remember, for physics, it doesn't have to be X and Y. That's really generic. It could be any variables, right? You guys made those flashcards with all those variables. It could be, or it might even be like variables multiplied together. Like you guys remember with the circle, you did like area versus R squared, and that came out to a linear relationship. Okay, so X and Y is just stand-ins for anything. Okay, what if you do a lab and let's say you change the X value, right? So you try all these different inputs, like your independent variable, and you get this for Y, and then this for Y, then this for Y, then this for Y, where it's kind of just bopping around like the same value over and over and over again. What does that mean? Does Y care what X is doing? No. Y is just like, I'm doing my own thing. I don't care what X is. X is could be this little value, could be 4 times as much, and I'm just gonna keep saying the same thing over and over. That means that there's no relationship between the 2 variables, right? You could make X 10 times and Y's like, I don't care. I'm just going to be doing what I'm doing, right? Anytime you see a variable canceling out, ooh, maybe that's means there's no relationship, say between V and M. I can make the mass twice as big and V's like, I don't care, right? Well, what about this? What if you get something that's basically like a vertical line? Is that like this same interpretation? No relationship? But now it's the other way. Now you're changing Y, but X is like, I don't care what Y is. I'm just going to do the same thing. Okay, let's go. A pretty common one you'll see is did something like this last week. What if all the points line up like that? Could I call that direct relationship? I'll say direct or linear. Okay. Now, a lot of times these graphs will go through the origin, but not necessarily. Okay, so if they go through the origin, you might just say Y equals MX or Y equals KX. Y equals MX where the slope I might call M equals slope. So M is like an algebra term in this case. If you get Y equals MX plus B, isn't that plus B going to shift this up or down vertically? Okay, you might get some points that look kind of like this. Actually, we did one of these graphs last week already too. Okay, like this. What's this called? Parabola. Yeah, we're going to go for parabola. So I'll say power. Now, if it's a power of 2, and a lot of times that's how it works out in this class. Then yeah, it'd be a parabola. Okay. That's like some version of Y equals X squared, Y equals X to the 3rd, Y equals X to the 4th. If it is Y is X squared, then it would be a parabola. Okay. And it might have some constant in front, like Y equals 3X squared. You guys get that? Okay. Guys, is that exponential? No, right? Exponential is like Y equals 2 to the x, where you put the variable in the exponent, which at a glance might look kind of like this to start with, but it's a completely different class of curve, and you'll almost never see that in this class. But y equals x squared, you see all the time. What if you get something that looks like this? It looks kind of linear, except that maybe an origin point would be a pretty logical point to have. And you think, I bet it's hooking kind of like that. What do you guys think that is?
Logarithmic?
Okay. I do like both those answers, especially the square root one. So generically, this might be a root, for example, a square root. Okay. If it's y equals square root of x like this, or as a power, what would that be? X to the power of what? 1/2. Yeah, you guys got that. Okay. If it's x to the power of 1/3, that's the same thing as a cube root. X to the 1/4 is the 4th root. Okay, so if it's a fraction power, then it looks like it's going to hook down kind of like that, right? Now, if you said logarithmic, it almost looks logarithmic, except logarithmic actually has a vertical asymptote here, like goes down forever. And it's not logarithmic for the same reason that this one on the left is not exponential. I mean, at a glance, it might almost look like it, but it's you'll almost never see that in this class. Maybe here and there. Okay, and this last one I'm going to do. What if you increase x and that causes y to decrease? What do you think that would be called? Starts with an I.
Inverse?
Inverse. Yeah, where they're like reciprocals of each other. So y is I shouldn't say equals, I should say like proportional to, but proportional to, I guess, right? Like 1/x, some version of that. Okay. Okay, so those are the graph shapes to look for when you guys are doing a bunch of labs this year. Let me throw one more graph shape on here just because it might pop up a few times. I actually will pop up a few times. It's one called sinusoidal. So that's why I said it actually, if you get anything that looks like some version of this. Right. Now, if it starts at 0, 0, then it might be some version of y equals sine x, something like that. Or, I mean, this is just a like really generic way to say it. If it starts up here, it might be cosine. Sine and cosine have the exact same shape, right? You can just shift them. Oh, so we got. Okay, I got through most of the stuff I want to do today. So, yeah, you guys have a great rest of your day. Continue this adventure tomorrow. Yeah, you too.